Tell me what is the output of the program. Pause the video, try to figure out, and write your answers down in the comments. Done? Did you figure out what's the problem here? The add function accepts two 64-bit integer values, but we are sending 32-bit integers to add. Result? Error thrown by the Rust compiler. Then how to resolve this issue? We can change the argument types for the function, but then we lose the functionality to add two i64 values. Perhaps we can add another function specifically to add i32 values. That would work, but do you see the problem? Same function, just for different types, so code is duplicate. Right now, we are just dealing with i64 and i32. Imagine if we want the same functionality for other integer and float values. There would be so many functions for the same functionality. The best solution here is to have a common function for all the types where two values can be added, like all signed and unsigned integers and float values. Not any string or boolean values, because there can't be any math operation on those. Generics help us to achieve this exact thing. So here in this function, instead of using integer type, we can write a generic type. I'm just using t to denote this type. You can use any character, really doesn't matter, but better to use something related to make it readable. Using t is more of a common convention for type. Okay, so the function arguments are of t type, and we want to have the same as the return type as well. Now what is this t? Like it is neither a primitive type nor a compound type. So we need to define it. We can define it here inside the angular bracket. Now this t is the generic. This means that it can be of any type, literally any type. But in our case, we do not need any type. We want only those types which can be added, like mathematically added. So we need to define that here by using the add trait. Trait means behavior. So we want this t to be only those types which can be added. And after adding, the output should also be of same type. This becomes a complete implementation of a function that can add any two integer or float values. And all these become possible only because of generics. So generics help us write flexible, reusable, yet type-safe code that works with multiple types. What you have seen is generics for functions, and it will be same for methods as well. Now let's look at how we can use generics in structs. This struct contains points for x and y. The values are of type i32. So we can't use this struct for other types. We can use generics here. X and y can be of type t. So we have point of t. This t here is a placeholder for a type. Now we can create a point for i32, u16, f64 or any other type. There won't be any error. We can also have the implementation block for this struct. This IMPL block needs to know that the generic t is used here. So t has to be introduced here first. So this means implement for any type t in point struct using t. Then we can create an add function which will add another point with self and return the result as a point. Here in the point expression, we can add x of self with the x of other. Same for y. Since we added two generics, these x and y should have the add trait. So we need to mention that for the generic here, like in the previous example what we have seen. Now we can declare 2 points and then add them to get the sum. Output of this program will have the 2 points added for x and y. Do you remember the option enum from our earlier videos? This was the implementation. Does it make sense now? This t inside angular bracket is for generic. This means the enum holds sum of a value, and this value can be of any type without any condition. Same goes for the result enum, except there are two generic types. T is what you get when successful and E is what you get when failed. In Rust, types must usually be known at compile time, and for types we don't know, we use generics. Imagine a function that accepts an array and prints all the elements in that array. So when declaring this function, we need to specify the array length. And if we mention a specific length, then we can't send an array of any length we want. We always have to send the array of that specific length. What we really want is to have the function accept array of any length. That's when we can use something called a constant generic. So we can modify this array signature to get n values. Since we used a generic, we need to define a type, and this would be a constant value of type usize. The type of this generic will always be usize because when you mention a length or size in Rust, it is always usize because size cannot be negative, so unsigned, and Rust wants the number to match the architecture. That's why it is a usize. Like when you define an array, you just mention the size here as an integer. Rust internally treats it as a usize constant. Now, while calling the print array function, we can send array of any size. It will work fine. So you can see generics help us generalize code for multiple types. It achieves huge performance at zero cost using monomorphization, that is generating specialized machine code for each concrete type used with generic code. That's all for this video on generics. Don't forget to like and subscribe. It really helps the channel grow. In the next video, we'll dive into another powerful Rust concept. Until then, keep programming in Rust.